Okay, math junkies, dot product. You may have seen dot product before, maybe in physics, probably in this form here. Maybe you were calculating the work done when pulling a wagon this distance and with a force vector like that. Anywho, we're going to go in a more abstract setting, of course, being mathematicians. So what you do for dot product is you multiply corresponding entries and then add all your products. So I want you to try this exercise. So pause and try that. So for A, we get 3 times minus 2 is minus 6, plus 0 is minus 6. For part B, we're going to use this formula to find theta. So x dot y is equal to length of x, length of y cosine theta. So that's minus 6 on the left. We found that in part A. The length of x, just looking here, I can see it's going to be 3. The length here is root of 8, which is 2, root 2 cos theta. So what do I get? I solve for cos theta. Cos theta is, if I solve this, what do I get? Minus 2 over root 2. No, that can't be right. Minus 1 over root 2, which is same as minus root 2 over 2. So therefore, theta is, well, there are 2 answers on the trig circle between 0 and 2 pi, 3 pi over 4, or 5 pi over 4. And when doing dot products, we usually choose the smaller angle, as you can see right here. We don't choose, this angle. We choose the smaller one. So take 3 pi over 4. If you draw a picture of these 2 vectors, you will see what I mean. Okay, a couple of remarks here. You can do a dot product, and it's equivalent to this product of matrices. This is a n by 1 matrix, and this is a 1 by n matrix. And if you do a dot product of x with itself, you get this guy. Okay, I want you to, as an exercise, verify these two things. Okay, especially the second one. This is very much worth your time. So pause and try that, and let me know during class if you have any trouble. For now, we'll move on. Okay, Theorem 5.3. Okie dokie. So just some arithmetic, collecting some arithmetic facts here. Doesn't matter which order you do your dot product. We have a distribution property. And this constant c can move around as we please. You can also do, x dot cy if you wanted to, for whatever reason. When you do x dot x, what do you get? Well, x dot x is x1 squared plus x2 squared plus dot 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 plus xn squared. Now what? Well, that is at least 0. That is at least 0. All these terms are at least 0. So it's pretty clear that if you add up some non-negative numbers, you will get a non-negative answer. And if it is 0, it is 0. What does that mean? Well, how can you have x1 squared plus x2 squared plus blah, 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 xn squared equal to 0? Well, how is that possible? It's only possible if every term here is on its own equal to 0. Because if, say, this one were bigger than 0, it could never be canceled out by something else, right? So that means all these things must be 0. So we'll say if and only if xi squared is equal to 0 for I equals 1, 2, all the way up to n. So what does that mean? The vector x is all zeros. Okay, all these individual entries are 0. Okay, let's try a example here. Pause and copy. Okay, so what does it mean to be orthogonal? Okay, orthogonal is going to mean exactly one thing. It means the two vectors, when you dot them, you get 0. Nothing more, nothing less. Okay, so for this example, I'm going to draw just a picture that's not meant to be taken literally. I'm going to do a lot of this in chapter 5. I just draw a picture to help me think about the scenario. So I want to show that one of these angles is 90 degrees. So I need to show that let's see, that the angle between this vector and this vector is 0, or maybe some other angle between two sides. So I'll say, first of all, AB and is 90. Or maybe angle between, let's see, BA and BC is 90. Or the other possibility is that this angle is 90. So angle between CB and CA is 90. So how am I going to do that? Well, I'm going to look at my formula, which is x dot y is equal to length of x times length of y cosine theta. So look at that guy. I'll move it down here. So looking at this formula, oops, what can I conclude? I can conclude that theta is 90 if x dot y is 0. So what I'm going to do, because if I have theta is 90, that makes this thing 0, which makes this thing 0. So x dot y must be 0. And the other way around, if x dot y is 0, we know that our lengths here are going to be non-zero. So that will imply that cosine of theta is 0, which means theta is 90 or 270, but we're talking about interior angles of a triangle, so it's going to be 90. Okay, so what I'll do is I'm going to find this dot product here between these two vectors, and likewise these two and these two. I'm going to see that one of these dot products is 0. Okay, so let's go green here. What is AB.AC? AB.AC. So remember how to find AB. To find AB, you take this, you take B, and you subtract A. So B subtract A is 7, 2. And to find AC, I do C minus A. So that's 2, negative 7. So just looking at that, I can see that's not 0. So I'll move on. BA dot BC. Okay, so BA is going to be the negative of AB. BC, to find BC, I take C, subtract B, and I get negative 5. Oh boy. And then negative 9. So yeah, I can see that's not going to be 0. So finally, I'll look at CB.CA. Five, 9 dot negative 2, 7. 14. Oops. So this is also non-zero. So what have I done? Oh, I was being silly. Silly Billy over here. right? That is actually equal to 0. So, okay, really, I did not have to do any of this here. So what does that tell me? It tells me that this angle here is 90. Let's say angle at A is 90, and that shows that we do have a right triangle.